Alright, so we have your normal boundaries, and now we're going to remove those. So for x, we have, we know it's 60, and then plus, well, it's a multiple of 360. Right? We just keep going round and round and round this cycle there, so let's call it n times 360. We can also go down, go into the negatives, and we also have a multiple of 360. So n has to be an element of all the negative and positive whole numbers, so like -3, -2, -1, 0, all the way to wherever. So n has to be a positive or negative whole number. What are those numbers called? Integers. Perfect. So we call it a z with like a double body down the middle. So to generalize our general solution, this would be an unknown, or this would be based on the angle that's equal. So the actual solution should be, I guess, so exact same thing, 60 plus n times 360, negative 60 plus n times 360, for n being an element of the integers. That makes sense? We're just basically generalizing everything. Alright, so let's do example 1. Find all solutions to root 3 plus 2 cosine x equals 0. X is in radians. Alright, so let's take this first and let's move it around. So we can move that to the other side. So 2 cosine x equals negative root 3. And therefore cosine x is negative root 3 on 2. So we can solve for that. Negative root 3 on 2. Exact values table. So it has to be negative. So where is it negative? There and there. Put 3 on 2? What angle is that? 30. So we want it in radians, and we want it there and there. 5, or in this case 5 pi on 6. So x is, or can be 5 pi on 6, or I guess 7 pi on 6, because we're going that way. But we want all of them. So x is actually 5 pi on 6 plus n times 2 pi. 7 pi on 6 plus n times 2 pi. For n being all the integers, being an element of the integers. Now that is 7 pi on 6, but it's also negative 5 pi on 6. So you can also see it like this, plus or minus 5 pi on 6 plus n times 2 pi. Or let's make it a little bit neater, 2 pi n plus or minus 5 pi on 6. So you can write it like this, or you can write it like this. Both ways are fine. Okay, so that makes sense? All good, Daniel? Give me a thumbs up. So next one is a little bit not too bad. Click here. So we have sine x equals root 3 on 2. So find all solutions. Or sine x equals root 3 on 2, x in degrees. Okay, so let's see. Well, let's draw a little diagram here. Sine can be there. Sorry, it can be there and there because that's positive and positive. Sine root 3 on 2 is 60. Excellent. So 60 there and 60 there, which means it's either 60 or 120. So x is 60 or 120 plus n times 360 for n being an element of integers. Alright. Last one. Actually, no. Second last one. We'll do that one by yourself. So that's example 2. That's example 3. That one should be pretty simple. And we'll do an example 4 as well. If it doesn't specify x, always do radians. Let me just do the roll. There we go. Alright, so pi on 3 and pi on 3. So in this case, because it's not reflected, we can actually just write it like this: x equals, or n pi plus pi on 3. Because look, if I'm adding pi is 180 degrees. I just keep going, and that way. So that's my first one. That's my second one. That's my third one. That's my fourth one. That's my fifth one, and it keeps going. So all I need to do is add pi, and I keep finding all the solutions. That one makes sense? So it's a visual thing. Last one. So find all solutions correct to 2 decimal places. Whew. So we're gonna need obviously a calculator for this one. Nothing too bad. We just go shift 10, 0.6, and it says, right, well, that's 0.54. So I've done 10 inverse, 0.6, and that's 0.54. Now I don't really want to round to the very end, but I'm gonna leave that there so I can use it as my answer later on. So I know that this guy is that. I know that this guy is that. So 10, the angle should be 0.54 radians. So roughly there, say 0.54, and then we go that one as well, 0.54. So obviously we want our solutions to be like that, and then we keep going. That would be very easy. We just pop that into there like how we did our last question, and we would solve. But of course x is a little bit complicated now because we've got that in there. So that should equal, so pi on 2 brackets 2x minus 1 equals n times pi plus 0.54. Normally that would be x, but it's not x. It's this big thing. So we're just going to have to move it around. We'll move that to the other side. Move the 1 over. And divide it by 2. So let's simplify this first before we divide it by 2. 2n, because the pi's cancel out, plus 2 times that. So we'll go 1.08 over pi and then plus 1. And then now we divide everything by 2. We divide it by 2. That's n I'll go this way, n plus plus half, so divided by 2 pi plus 0 even higher, and plus 0.67. Let me just double check that. Yep, 0.67, and that's your answer. So just make sure you write this bit down where n is an integer and then rounded to 2 decimal place.